Good evening. Welcome to the ninth live session of Principles of Industrial Engineering. So today we'll be discussing on different forecasting methods. We'll starting with some theoretical questions and then continuing with the numericals. So let's start the session in a bit.
Good evening. Welcome to the 9th session of Principles of Industrial Engineering. So today we'll be discussing on basically on forecasting, different types of forecasting techniques, qualitative, quantitative, long range forecasting, medium range, short range forecasting, and the time series model. So, so let's start with the question. The first question is, which statement is common in both network approaches, CPM and PERT? CPM, and these are some of the questions based on the topic which we discussed last time, critical path method and PERT method. So both CPM and PERT, these are based on which type of model? Probabilistic model, deterministic model. They both require planning, schedule and time estimation. Both are equally applicable in handling of all projects. So the correct option is both require planning, scheduling and time estimation. And rest regarding probabilistic model, deterministic model, we have clearly discussed last time which models include which type of which techniques include which type of model. You can refer it. Okay. So moving on to the next question. The critical path in a network of activities cannot be delayed, or else the entire project will be delayed. Must have at least 3 activities. Will be the path with the most number of activities. Will always have all activities with positive slack. So here the critical path, as we know that if a critical path is a network of activity, it cannot be delayed. If it is delayed, the entire project will be delayed. Thus, this is the correct option. And rest all, it's not necessary that it will have a positive slack, or it will be the path with the most number of activities, or it must have at least three activities. These are not uh, specific, not specific that if these points. Okay, so the next question. Forecasting method used to forecast the demand for launching a new product is which of the following? When a new when a new item is launched, and demand record is not available, then we use the judgmental method. This is the method where we use it to launch a new product. Okay, so now we will discuss elaborately what is forecasting. So, in forecasting, this means estimation of future demand. Now, it has a qualitative technique and a quantitative technique. Now this qualitative technique, this is based on human judgment. And this is based on projection of part data. So, when a new item is launched and demand record is not available, we use the judgmental method. Now, the rest methods, moving average method, market research, exponential smoothing, we will discuss one by one as we discuss the next question. But we'll discuss a brief on the qualitative techniques, which is this is one of the qualitative technique is Delphi technique. It is one is direct survey, or consumer survey, or market research. Next is sales force opinion. These are some of the qualitative techniques. Quantitative techniques is based on projection of past technique. Now we'll discuss what is a Delphi technique. Delphi technique is an iterative procedure in which series of questionnaires are given to management and staff, and based on the answers a common value of forecast is decided. And the sales for opinion is drawback is salesperson are sometimes highly influenced from recent data. So direct survey or consumer, this we know, the surveys or opinion polls which are conducted so as to know your opinions or views. So moving on to the next question. The time series forecasting method that gives equal weightage to each of the m most recent observations is which of the following? So now we will discuss briefly on all these methods. Moving average, exponential smoothing with linear trend, triple exponential smoothing, and Kalman filter. Now, when we go now in the quantitative technique which we discussed in the previous question, here we have two types of models. Demand is in hundreds. Now, suppose demand, this is demand, this is population 25,000. Demand is 400 for a population of 30,000. Demand is 300 for a population of 27,000. This is the Cashman method. Okay. So, as per the current question, the time forecasting method that gives equal weightage to each of the most recent observation is the moving average method. Now, in this constant or local demand model, now the time series model, as we discussed in the quantitative technique, the time series model the demand pattern can be different. One will be constant constant or level, another will be trend, another will be cyclic variation. Now this may increase or decrease. Suppose if I put it in the graphical form, this will be like this, this will be like this. Just a rough example, this is the demand, this is the time. Okay, this is just an example. Here it decreases. Again, if we have the curve like this, it will be increasing. Now, in the constant type of pattern, this is like there are very slight fluctuations. In the trend pattern, there are long-term upward or downward movement in the demand data. In the cyclic variation, this is like wave-like variation lasting for more than 1 year. This may be due to economical or political reasons. Now, and another also, these are some other variations also, like seasonal variation, and irregular variation. Seasonal variation is like, suppose the demand of woolen items go higher in a winter season. That comes seasonal variation. In a particular time only. Now, irregular variation is like the demand for masks grew very high during the COVID period. That is known as irregular variation. Okay, this is the demand. Now this is the constant time series model. Now when we go for the constant, or as we discussed, the quantitative technique had time series model and casual method. Now the other method, constant or level demand model. This has simple average method, weighted average method, simple moving average method, for weighted moving average method, last one is exponential smoothing method. And the exponential smoothing method is one of the most important method of forecasting. Now I will take an example of a data, and based on that, so the weighted, as per this question, we have the moving average method. Here the moving average method, yeah, the moving average method, if we write in formula, it is the, here's what happens, the most weight, maximum weight is given to the most recent data. So, in the simple moving average method, what happens, the difference is so I'll just write quickly the formulas for all the methods. Simple average method, here forecast is equal to summation of all demands by number, total demand. Okay, now the weighted average method is here the sum of all the weights is equal to 1. Now forecast is equal to summation of WIDI by WI. Now the simple moving average method f of n plus 1 is equal to di and weighted moving average method for example, this is 0.5 into D5, 0.3 into D4, now exponential smoothing method. alpha dn plus 1 minus alpha into fn. Now here fn plus 1 is equal to forecast for n plus 1 period demand for nth period f of n is equal to forecast for nth period alpha is equal to smoothing constant. Now if we maximize this will be alpha dn plus alpha fn. This will be fn plus alpha dn minus fn, and this is the forecast error. This is the only method which takes care of forecasting error. Okay, so we discussed nicely upon all these concepts. So next question. In a high noise demand pattern, forecasting data lies well. This is a case of where there is a irregularity. So this is a seasonal variation, or so here what happens is this is far from the actual demand data, because here this is short term regular variation at a particular time. Example we can give as demand of woolen clothes in winter season. This is like at a particular time and particular year. Okay, so the next question. In which of the following forecasting techniques subjective inputs obtained from various sources are analyzed? Time series forecast, associative model, judgmental forecast, all of the above. So here the correct option is judgmental forecast. We already discussed what is a judgmental forecast, which is based on human judgment, and that includes various type of techniques such as Delphi technique, history analogy, Salesforce opinion, direct surveyor, consumer mark research, or jury. Sometimes we take jury of executive opinion also. The time series forecast we discussed, associative model we discussed. Next question. An electronic manufacturing company wants to predict the demand of LED bulb for certain period of time, and company having past demand data of the same of January to June 2021, which is 100. So here they want to know the forecast of demand in July 2021 through simple average method. Now, simple average method. Now here, simple average method, we know that Fn is equal to summation of the demands by number of demands. So here, sum of all the weights, as we know, is equal to 1. Now we have 1, 2, 3, 4, 5, 6. So we have n is equal to 6. So the each weight is 1 by 6. Okay. So forecast for July 2021 is equal to 1 by 6 into 100 plus 1 by 6 into 150 plus 1 by 6 into 300 plus 1 by 6 into 180 plus 1 by 6 into 200 plus 1 by 6 into 230 6. This becomes 1160 by 6 is equal to 193.33. So, any doubts till now? all the demands. But in the weighted average method or moving average method, the demand for weights are different for different demands. Right? Okay. So okay, this we can also write simply rather than complicating this as we can also write it as 100 plus 150 by 300 plus 180, just summation of all the demands by number of demands. So the next question, the most appropriate time series method that needs less past data for forecasting is which of the following? The time series method that needs less past data for forecasting is exponential smoothing method. As we know, here we have we can know the forecast errors. So this is the only method which takes care of the forecast error. So we discussed the last question in the simple average method, moving average method, weighted moving average method, exponential smoothing method. We have already discussed all the formulas. So we will just understand the methods in the coming question. This is the only method which takes care of forecasting error. In exponential smoothing forecast, to give higher weightage recent demand information, the smoothing constant must be close to. Now, here in exponential smoothing method, ft is equal to ft minus 1 plus alpha dt minus 1 plus f minus ft minus 1. So, when for alpha is equal to 1, we will have ft is equal to dt minus 1. So, when higher weightage is given to recent demand information, the smoothing constant will be close to 1. Now, the sales of the product during the last 4 years were 860, 880, 870, 890 units. The forecast for the fourth year was 876 units. So, here the question is asked to solve it by 3-period moving average method. Three-period moving average method. Now, here it is asked to find out the value of exponential smoothing constant. So first, exponential smoothing constant, first we have to find out the forecast of the fifth year. So we have to forecast using a 3-period using average method is equal to 5. We took only the we have to, since it is a 3-period moving average method, so we have to take the recent 3 data, 880, 870, 890 by 3, this will be 880. So now using simple exponential smoothing, F5 is equal to F4 plus alpha D4 minus F4 . The forecast for the 4th year is given. We have to find out the alpha. Demand for the 4th year is 890. Forecast for the 4th year is 876. Now, solving this, you will get the alpha as 2 by 7. So, in this way, we find out. So, you have to be very careful because here it is written that you forecast for the 5th year using simple exponential is equal to the forecast using a 3-period moving average. So it is giving the hint that the forecast for the 5th year can be found out by a 3-period moving average method. Okay, so the next question. The demand for a two-wheeler was 900 units and 1030 units in April. Demand of April is 900 units. Demand of May is equal to 1030 units. Now, the forecast for the month of April is equal to 850. Smoothing constant is equal to 0.6. Now it is asking for the forecast of June. Now, so here first you will find out the forecast for May, then you will find out the forecast for June. The forecast for May will be forecast of April plus alpha into forecast of April, demand of April minus forecast of April. So this will be 850 plus 0.6 minus 900 minus 850. So after solving this, you will get forecast of June, which will be forecast of May plus alpha, demand of May minus forecast of May is equal to, so first we will find out this. This will be 880. Now 880 plus 0.6, demand of May is 1030 minus 80 is equal to 970. So the correct answer is 970 units. The next question, an exponential smoothing trend with alpha and beta are same and used as smoothing constant coefficient for the smoothing coefficient for the forecast and for the trend respectively. This is the correct option. Next question. The actual demand of 105 forecast value the actual demand of 105, forecast value of 100, smoothing coefficient for the forecast of 0.5, trend value of 10 and smoothing coefficient for the trend is 0.3. Determine the new forecast and the new trend. So in this question we have to find the forecast, which is now here we know smoothing coefficient for the forecast is given, smoothing coefficient for trend is given. So first we find out the forecast using the smoothing coefficient for the forecast, and next we find out the new trend using the smoothing coefficient for the trend. This is 108 and 9.4. Okay, so the next question. A non-critical, this is again a question from the critical path method. Here the earliest finish time and latest start time is given. The slack time of the non-critical activity is being asked. So we discussed a similar question like this last time also. The slack time is all earliest finish time minus late finish time. Now here the earliest finish time is minus late start time, sorry. So it is 28 minus 22 is equal to 6 weeks. Slack time is 6 weeks. Okay, so this is the network diagram. We have to find out the slack start time of the activity H. So I will just draw the network diagram. I will find out the slack time of the network diagram basing on the activity. So now from 1 to 2, node 1 to node 2, the activity A, the time is duration is 3. So here the is 0. Start time is 0 and the end time is 3. Now for node 1 to 2, for activity B, their time duration is 1. So the start time is 1. Now for activity C, the start time is 3 and this and 6. For activity D, it is 3 now you will see that activity date starts from 2 and it reaches at 5. Now when it starts from 2, we have to see which is the least time. It is 3 and 4. For activity E, it is 1 and 2. F, it is 1 and 2. Activity G, it is 4, 5. Activity H, it is 5, 6. Activity it is 6 and 7. So the start time is 5. So the next question, long-term forecasts are done for which of the following? Scheduling, controlling, capacity planning, all of these. Long-term forecasts are done for capacity planning. The continuous increase in demand or consumption as a function of time forecast. Okay, this we already discussed. As a function of time, where we discuss the time series model, which has constant trend, cyclic variation, seasonal variation, irregular variation. When it is increase in demand or consumption as a function of time, then it is referred to as trend. Trend you have, this is demand curve, this is time, this is known as trend. This can increase or decrease. Now, long term upward or downward movement in the demand data. Seasonality, trend and seasonality variation, trend and seasonal variation, irregular variation we have already. Apart from this, there is also residual or random fluctuation. Here the variation remains in the system when all other variations is very ad hoc, when all other variations are we have taken into account, but still some variations are come into account. So that is known as random or irregular variation. So the next question. Forecasting of manufactured goods is in the form of raw material, semi-finished, finished, all of these. Well, the manufactured goods are forecasted in all types. Raw material, semi-finished, finished. We cannot just forecast a product based on a single criteria, because the course of action will change, taking into account all the things, raw material, semi-finished and finished, all things in for the product. Now, the preferable method for forecasting new products is quantitative technique, qualitative technique, moving average, linear regression. So the most preferable is quantitative technique based on human judgment. Qualitative, based on human judgment. Which we already discussed. This includes on various types: Delphi, history, analogy, jury of executive opinion, Salesforce opinion, direct survey, consumer survey, market research. The forecast for the next period demand is based on the most recent data. This is known as naive method, simple average method, Delphi method, linear regression method. Here, this is known as the naive method. Well, Delphi method, it is an iterative procedure in which series of questionnaires are given to management and staff, and based on the answers, a common value of forecast is decided. Iterative procedure in which series of questionnaires are given to management and staff and based on the answers a common value of forecast is decided. And linear regression, simple average method, we already discussed. Simple average method is where we just do the summation of all the demands and divide it by the weights, and here the past demand data is considered and equal weightage is given to all the demands. Summation of the weights is 1. Naive method, here forecast for the next period demand is based on the most recent data. Now what here it is done is, now here problem is encountered. Think if you should give more weight to recent data or when compared to old data or not. So in this type of method we use that we give it to the most recent data. Now we can also Now linear regression method. This is a trend variation where there is increase or decrease in trend. This is the linear regression method. I will just grow brief. This is the graph. This is the trend. Okay. This is the demand. This is the time. Now, suppose this was the demand now at this time. Let us consider it as yi. After some time, the demand is this. Now, what we will do is we will describe summation of yi is equal to, let's consider this is a plus b ti. These are x points. Now yi by here what the end is v, this is the first equation in a linear regression analysis. Now after doing the derivation and everything, we get summation of ti vi by I is equal to a into summation of ti plus b into ti square. Now this is the linear regression method. Okay, so the next question, the smoothing coefficient and exponential smoothing for method of forecasting varies from now here the correct option is 0 to 1. Now the smoothing will discuss a little bit on the smoothing coefficient. Higher value of alpha, lower value of alpha. This is for unstable demand. Stable demand. So when higher value of alpha, this means more weightage is given to demand than forecast. Smaller value of alpha, this means more weightage is given to forecast than demand. So system, so in so when we have a higher value of alpha, there will be a smaller smoothing effect. And with a smaller value of alpha, there will be a higher smoothing effect. Suppose here the graph will be like this. And here the graph will be like this. So here less number of demand points are used while computing, while here more number of demand points are used while computing. Okay, so the next question. The demand per product is given. The forecast for April. Forecast of April is 100. Now it is asking for the forecast of July. We have already discussed smoothing coefficient is saying as 0.2 and this is the demand data. So first we will find out the forecast of May. Then we will find out the forecast of June. Then we will find out the forecast of July. Forecast of May is forecast of April plus alpha into forecast of April minus demand of April. Similarly, forecast of June is equal to forecast of May plus alpha into forecast of May minus demand of May. Forecast of July is equal to forecast of June plus alpha into forecast of June minus demand of June. Okay, uh, just I just did it opposite. Okay, with this, after solving, you will find out and your final answer will be, I'll just solve it quickly so that it will be clear. This will be 100 plus 0.2 into 100. This will be 120. Will be 120 plus 0.2 into 50 minus 120. This will be 106. 106 plus 0.2 150 and so that it is clear, you can always make a column for this: month, demand, forecast, write the data April, May, June, July, right, 200, this is 50, 150, question mark, this will be 100, 120, 106, 150. So the correct answer is 150. Next question. High exponential smoothing constant, an average likely to change low exponential smoothing constant when the underlying average is stable. So which of the following is correct? The correct option is both statements are true. We just discussed a high exponential smoothing constant will have more fluctuation and a low exponential smoothing constant will have less fluctuation. So, in a high exponential smoothing constant, the averages change. Average will change for sure. System will be more responsive to change. This is the high exponential smoothing constant. This is the low exponential smoothing constant. So here system will be more responsive to change. System will be less responsive to change. Higher value of alpha is used for unstable demand. Smaller value of alpha is used for stable demand. This is a difference. Okay, so we reached to the end of the questions. Any doubts so far? Okay, so if there are any doubts also later, you can ask always in the um, discussion forum in the website. So, okay. Okay, so we'll just end the session. Thank you all for attending the session. Let's meet again next week. Thank you.